Hi everyone, this is Mrs. J, and today we're going to learn about arithmetic sequences and series. So I have a quick warm-up for you guys, so please read the directions and give it a try. Pause the video, and when you're ready to check, just hit play. Alright, go ahead and check your answers here. So hopefully you notice for the first list of numbers, the pattern is that you add 6 to get the next term. So our next three terms would be 22, 28, and 34. And for part B, you might notice that we're subtracting 50 to get the next term, so these would be our next three terms. All right, so before we talk about specifically arithmetic sequences and series, I want to talk about some general vocabulary for sequences and series because this is a new concept for us. So a sequence is simply an ordered list of numbers, kind of like what you saw in the warm-up. Those were both examples of sequences. Each individual term or each individual number in a sequence we call a term. So again, each spot is a different term. There are different ways you can describe a sequence. You can use what's called an explicit rule, and this is what we're going to be focusing on. And an explicit rule is a rule for a sequence. It looks like an equation that defines each term relative to its position in the list, which we call n. So if it's the first term, n is 1. If it's the third term, n is 3. So this rule, again, describes the term in reference to its place in line. There are also what are called recursive rules. We're not going to be using them in our class, but it is a rule for a sequence that defines each term relative to the term before it. So it's essentially a way for it to say, hey, take the term before and multiply by 2 or something like that. And then a series is simply when you take the terms in a sequence and you add them all up. So it's the sum of the terms in a sequence. So essentially, instead of listing the numbers and separating them with commas, we would list the numbers and separate them with plus signs. So again, today we're going to be focusing on what are called arithmetic sequences and series. All right, so first we're going to practice just how to use an explicit rule. So this says find the first four terms of the sequence given the explicit rule. So here's an example of what a sequence looks like. So it says a sub n equals 5n minus 1. So again, they would like us to find the first four terms. So the first term happens when n equals 1. Remember, n is the relative position in line. So to find the first term, we're essentially doing a sub 1, and we substitute n with 1. So we can see that our first term is 5 minus 2, which is 3. So to find the next term, we're going to find a sub 2. So we do 5 times 2 minus 2, again replacing n with 2, and we get a sub 2 equals 8. So this means the second term in line is 8. And we can do the same for a sub 3. Again, the third term in line is when n equals 3. Oops. So minus 2. So a sub 3 is 13. And a sub 4, substitute n with 4. And we get 18. So the first four terms of our sequence would be 3, 8, 13, 18. And we list them with commas in between. All right, let's look at this next sequence. So here we have a new explicit rule, a sub n equals 3 over n. So again, to find the first term, we're going to find a sub 1. It's when n equals 1. So it's 3 over 1, which is 3. So the first term is 3. A sub 2 is going to be 3 over 2. Just substitute n with 2. A sub 3 is 3 over 3, which is 1. and a sub 4 is 3 over 4. So the first four terms are 3, 3 halves, 1, and 3 fourths. So again, notice for these explicit rules, the rules are written in terms of n, which is the relative position in line. This is when n is 1, this is when n is 2, this is when n is 3, and this is when n is 4. So now that we know how to interpret and use a sequence, we're going to talk about a specific type of sequences, which is an arithmetic sequence. So an arithmetic sequence is a sequence where the terms have a common difference. A common difference. So this is just a fancy way of saying that we essentially add or subtract the same number to get to the next term. They have a common difference. So we can write, once we've determined that a sequence is arithmetic, we can write the explicit rule for any arithmetic sequence with the following formula. So the formula is a sub n equals a sub 1 plus n minus 1 times d. So two things we will need to find. We do need to figure out what a sub 1 is, so what that first term is. N is supposed to be in our sequence, right? And then we also need to find out what d is, and d is that common difference. So if you can find what the first term is and what the common difference is, we can use this formula to help us write the explicit rule for any arithmetic sequence. All right, so let's give these a try. We're going to be writing explicit rules for these sequences. The first thing I want to point out is we do need to determine that it is actually arithmetic first. So if you look for a pattern, you'll see that to get from the first to second term, we add 2. From the second to the third, we add 2. From the third to the fourth, we add 2. So there is a common difference, and that d value is 2. So this is arithmetic, so we can make the explicit rule using the formula we just learned. So again, we have already found our common difference. I can see that a sub 1 is 1. You can see the first term in our sequence is 1. So now we just need to plug it into our formula, which again looks like this. So a sub n equals a sub 1, which is 1, plus n minus 1 times the common difference, which is 2. And then from here, all we need to do is distribute and combine like terms. So we have 1 plus 2n minus 2. So this gives us a sub n equals 2n minus 1. And this is our explicit rule for that sequence. All right, let's have a look at the next one. So first, let's make sure it is actually arithmetic. So let's see if there's some type of common difference. So I can see to get from -5 to -9, it's like we're adding, I'm going to say plus -4. Or you could just say subtracting 4. But typically we say what are we adding to each term. And then to get from the second to third, we're doing the same thing. We're adding -4, adding -4. So we can see that there is a clear common difference. The common difference is -4. And we can see just from the list that our first term, a sub 1, is -5. So now we have everything we need to make our sequence. So again, we're going to be using this formula that we used in part A, and we'll substitute what we know. So a sub n equals a sub 1 plus n minus 1 times our common difference, -4. We'll distribute -4, so -5, and then we get minus 4n plus 4. So our explicit rule should be -4n minus 1. And there you have it. Alright, so at this time I'm going to ask that you pause the video and please give these two a try. When you're ready to check, go ahead and hit play. Alright, so go ahead and check. So for part A, you can see that our common difference is positive 5. A sub 1 is negative 6, our first term. So plug it in and you should get 5n minus 11. For part B, our common difference is actually negative 0.2 because we're decreasing in value. And our first term, a sub 1, is 2.6. So when you plug it in and distribute, you should get negative 0.2n plus 2.8. All right, so now we're going to move on to talking about sigma notation, which is a way we can write a series or way we can represent a series. So remember from the first slide, a series is simply when you add up the numbers in a sequence. So again, a sequence could look something like this: 2, 4, 6, 8, ... And a series, again, the only difference is now we're adding up those terms. So it'd be 2 plus 4 plus 6 plus 8 plus ... So there is a way that we can represent a series using what's called sigma notation or summation notation. Now it's called sigma notation because it uses the Greek letter sigma. So you start by writing that. And then here on the bottom, you write the lower limit of your summation. So you would say I equals 1 if you want to start with the first term, or you would say I equals 5 if you want to start your summation at the fifth term. So it depends where you would like to start your summation. And then on top here, you write the upper limit of your summation. So if you want to go up to the 10th term, you'd put a 10 here. Or if you want to add up to the first 100 terms, you would put a 100 here. And then here to the right of your sigma, you write the explicit rule for your sequence. So we're going to practice using the sigma notation before we talk about the more specific arithmetic series. All right, so we're going to start by just practicing how to write a series using summation or sigma notation. So let's look at this first series. So first I'm looking at it and I can see that I'm adding up 4 terms. So the first 4 terms from a sequence. So I'm going to start by writing my sigma. Since we're starting with the first term, we say I equals 1. Again, we don't actually write what the first term is. We write the relative position in line. And then on top, I'm going to write 4 because we are adding up to the 4th term. This is the first term, second term, third term, 4th term. And here I'm using the variable I. Another common variable you can use is k, but I guess technically you can use just about anything. Sometimes you see n. And then here again we need to write what the explicit rule is for this series or for this sequence. So if I'm looking for a common difference, I can see from here to here I'm subtracting 7. From here to here I'm subtracting 7. Same here. So this is an arithmetic sequence. So we know that the common difference is negative 7. Our first term is 5. So we can make the sequence really quickly using our formula. So a sub 1 plus n minus 1 times negative 7. And now we need to distribute and combine like terms. So it's going to be 5 minus 7n plus 7. So our rule is negative 7n plus 12. So this explicit rule right here is what I'm going to write here to the right of my sigma. However, since we're using the variable I, that's what we'll use when we write it. So negative 7i plus 12. So this is just saying to use this sequence, and they would like the sum of the first through 4th terms, which is exactly what we see here. All right, let's look at part B. So again, here we can start with our sigma. Let's use the variable k this time. So we are starting with the first term. So it looks like our first term is -1. So we're starting with the first term. But here you'll notice it says, it lists out a couple of your terms and then it says plus ... So that means that it's actually going to be infinite. So we can say to infinity. And then our next job is to write the explicit rule for this sequence. So again, let's look for a common difference. You can see +1, +1, +1. So that must be our d value. Our first term, a sub 1, is -1. So let's make our rule using our formula. A sub n equals a sub 1 plus n minus 1 times our d value. So this gives us -1 plus n minus 1. So a sub n is n minus 2. So again, we're going to take this rule and we would write it here, except since we're using k as our variable, in this case we'll say k minus 2. So this is how you would represent the series that you see here in sigma notation. All right, so now that we kind of know how to set up a sigma notation or summation notation, we're going to see if we can actually interpret one and expand our series and actually find the sum. So in this first one, we have the sequence 2i minus 1. So that's our rule. So again, I could write this down here. And they would like us to find the sum of the first through fourth term, so the first 4 terms. So we are going to have to list out those first 4 terms. So a sub 1 is going to be 2 times 1 minus 1, which is 1. Our second term would be 2 times 2 minus 1, so 3. A sub 3 is 2 times 3 minus 1, which is 5. And our fourth term, a sub 4, is 2 times 4 minus 1, which is 7. So if I expanded out this series, it's 1 plus 3 plus 5 plus 7. That's what they're asking us to find. So all we have to do is add that up, and our sum is 16. And there you have it. Okay, let's have a look at part B. So for part B, we have the sequence given by the rule a sub n equals n squared, or here again they're using the variable k, but we can write it with n down here. So you can see here they want the sum of the second through 5th terms. So we're actually going to start not at the first term, we're going to start at the second term, and then we're going to end at the 5th term. So let's expand this out. Let's find those terms. So first, let's find the second term, a sub 2, which would be 2 squared, which is 4. The third term is 3 squared, which is 9. The fourth term is 4 squared, which is 16. And our fifth term is 5 squared, which is 25. So if I were to expand out what I see in the summation notation, they're just asking us to find 4 plus 9 plus 16 plus 25. Again, we don't always need to start with the first term. You can start with any term you like. So that's what that bottom number tells us. So now all that's left to do is to add up our series that we have listed, and we get 54. Okay, so here's the last 2 examples for this video. So please pause the video and give these 2 a try. So for the first one, you're writing it in sigma notation, and for the second one, you're expanding and finding the sum. Okay, so let's have a look. So for the first one, we're writing it in sigma notation. So we do need to create the rule for the sequence. So I can see that here our common difference is 4, and our first term is negative 20. This is an arithmetic sequence, so we can make the rule right here. So you should get 4n minus 24. And then from there, we set up our sigma. We are starting with the first term, so we start at I equals 1. We write our rule here using a matching variable, and then since it does have dot, 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 it's implying that this series would keep going on forever, so it's to infinity. Okay, for the second one, we're doing the opposite. We're actually expanding it. So you can see that they want us to use this sequence, 3n, or a sub n equals 3n, and they want the sum of the 9th through 12th term. So we have to find those terms. So the 9th term is 27, the 10th term is 30, the 11th term is 33, and the 12th term is 36. So if we expand out what this summation says is 27 plus 30 plus 33 plus 36, which gives you 126. Okay, that is all for today's video. Thank you so much for watching.